Hello, I'm Joshua Weiser, and this is the presentation for the 3D printing lab course for the Engineering 300. And my project was the 3D Arduino LED enclosure. The project purpose and design goals of this project was to just design a simple, nice looking enclosure for an Arduino board. And I used the Arduino Uno board, but it could also be used for a smaller board, for the Nano board. And I used this project to drive LEDs through using the translucent additive manufacturing material. Well, it's not necessarily clear, but you can still see the LEDs for it, and that was part of my goals. And then the other aspect I have for this design was to potentially add in speakers and a little IR receiver that could be used for IR remote, for an infrared remote that you could use to select different options on the LEDs or different lighting programs. So I also designed in little ports for each of those pieces, even though I don't have those yet. But at a later point in time, I plan on receiving these components and integrating them into this enclosure. The form, fit, and function objectives for this was to make the enclosure small, but not too small, obviously, enough to fit the Arduino board. And then I measured out future speakers that I would look at eventually obtaining and adding to this device as well. Same thing with the infrared receiver. So I made little ports in this design enclosure and had a way for mounting the Arduino board and also mounting a small breadboard also. And so that just allows for the whole enclosure for the Arduino board to be hidden and the LEDs to be in view via the translucent 3D printed material. And I use different shapes and different measurements to achieve my goals. And mostly was printing via the Cura and was also using the matter control programming to actually do the building. I did try Fusion 360 as part of that Gesh lecture recommended. He also recommended a couple of the paid programs, but I found that the matter control after researching on the internet was much easier way. So you could also 3D print straight from it. Although I did end up using Cura, just the idea to product lab did use Cura, so I was ended up using that as well for the actual printing process of it. So I just created different shapes and different things like that to actually make the design for the project so that I could actually attach the Arduino board and the breadboard and in the future speakers and the receiver, as well as having a USB port that could either power it or that could also program the Arduino board as well. So you could have different lighting programs. I just programmed in a simple fading in and out lighting program, but it could be used to have different lighting patterns, different timings. It could also come on different sounds with the addition of that speaker and a MP3 module that I'm looking into getting eventually, and will hopefully add to this project. Some of the features and highlights is using the Arduino board. I programmed a slow dim on and off of these four LEDs, and that's mounted onto the top, right where that cylinder is. It's basically just on the inside of that cylinder and is essentially hidden by it. But then you can, of course, see the LEDs um, dimming on and off through that enclosure. And then, of course, I have the ports for the USB and for the addition of a few more components later down the line. So it has some customizability, both in the programming aspect of the Arduino board and also the inner layout of the device too. And again, that can be used to do different devices. I did add in resistors just to make sure that the current draw on these LEDs were going to allow the device to be properly bright and as well as dimming in a fashion that I wanted to. And also use that Arduino board too to programming it using the pin 9 LED board, and that's the pin that I use for the programming also, and also a ground connection. So it's very simple connections here. Once I add in a speaker and the infrared receiver, there would be more pins on this Arduino board being used. You could also replace this board. This is the Uno board. There's a much smaller board called a Nano board that is essentially about as long as this, but will take up less width on this space. So you can actually end up using less space in there if you use an Arduino Nano board. And as you can see in this photo, you can see the speaker ports, and at the very top you can see the USB port. At the very bottom is where I have a port for the future addition of an infrared receiver. You could also put a button in there as well, so you could turn the device on and off. So that would be a potential difference. You could just do a 3D printed button enclosure that could pop in there and then be wired straight to the Arduino board. And so this is the top portion of this enclosure that's seen here in this photo. And that's basically on the opposite side of this Arduino board. And the cone that was shown at the very beginning, sorry, the cylinder and cone at the very beginning rest right on top of those LEDs. So that's the main features and highlights of this. It's just a nice enclosure for the Arduino board. And then some of the lessons learned that I had here is that 3D printing pieces can be difficult when you're trying to measure in and actually fit pieces to get to fit in correctly without use of screws or glue or anything like that. I was able to get the cone and the cylinder to fit in without any kind of additional support, and the actual cylinder into the box will fit in, but because of the raft that I had to use and then sanding I used to smooth it out, it doesn't fit perfectly. So that's one downside that I came across, was just be able to get parts to fit in. What I could potentially do is use like a hot glue gun and get this part to fit in that way. But then, of course, it would limit the access to the LEDs here. You'd still have access to the Arduino board itself and to any other components that you have in the internals of the box, because there's just this plate that gets mounted to the bottom of it. That can either be mounted through screws, or right now it's just mounted just through pressure. But I imagine as the parts age, since this is plastic, eventually those parts will wear a little bit. So I'll actually have to screw in tiny little screws into the bottom of this plate to be able to mount to this board. But right now it's just resting there through pressure. The other lesson I learned too was that I did try creating right where the cylinder and the cone meet. I tried to just make a little design strips, little rings around this design, just for like an additive visual aspect of this. It really actually didn't serve any structural purpose, but I was just playing around with different 3D designs, and I did find that this was far too delicate. I could have made it thicker, but then it would have done more obstruction of the LEDs. So I just decided to not use this design, and instead I just have just the cylinder and the cone here without the rings. And in the future, I could maybe look at different things I could put in front of that cylinder just to make different visual aspects of this cone. So I could have like a strip going down, or something to make the cylinder look different than just a translucent cylinder. And then other design things that came into was just the warping on the bottom plate. At the Idea 2 Project Lab, we did have to change around some of the calibration settings, some of the alignment settings on some of the Losbot 3, the Losbot 6 3D printers, just because I found that it wasn't printing correctly. The material would get just kind of swept around on the bottom of the plate, and it wouldn't adhere to the plate exactly. And so it created a warp shape, or would even have to be the print had to be reset once. Even with the automatic calibration, one of the technicians had to go in and manually calibrate some of the levels of the bed just to get the print to stick, even with the use of glue, of the Elmer, that glue stick that is used in the lab. So just some of the design aspects of this were just new to me. I did make a few prototype models and like a few keychains, just get used to 3D printing. But printing such a large object as this enclosure, or at least a relatively large object as far as 3D printing goes, it can just be difficult just because of the warping, and if there's any impurities on the plate still left over, or unbalancing issues, I should say, just makes it so that it's can be warped, and that parts don't fit exactly in as you would think, especially if it's printed right on the bed. If it's something that's raised up more, that's a millimeter, a few millimeters above that initial plate. I did get those to fit in easier, and just had a difficulty just with warping and things like that. So this is just the rest of the lessons learned of this project. And again, this is the 3D Arduino enclosure, and hope you enjoy this presentation. All right, thank you. Bye-bye.